The other application of integrals is finding the areas of regions. So, as you know, just as a reminder from Calc 1, you know that if f of x is a function that over some interval it is more than or equal to 0, meaning that the graph of f is above the x-axis. It doesn't go below the x-axis, like this picture here. Suppose we have a graph like this, y equals f of x. For a function like this, that f of x is more than or equal to 0, if we integrate over the interval from a to b, suppose a is here and b is here, the integral from a to b of f of x dx gives us the area of the region, which is bounded on the left by this vertical line, on the right by this vertical line, from the bottom by x-axis, and from the top by the graph of f of x. So it will be the area of this region. So this will be the area of this region that you see here. But here we want to find the area bounded by two functions, or the area of the region that is defined by two functions. For example, suppose I have say graph of f of x looks like this, y equals f of x. And let me use a different color. Suppose g of x looks like this, y equals g of x. And I want to find the area from a to b of the region which is bounded by these two functions, or which is enclosed by these two functions. So I'm looking at the area of this region. In this example, f of x over that interval from a to b, the graph is above g of x. So in fact, in this picture, over the interval from a to b, f of x is more than or equal to g of x. In this situation, when we want to find the area between the two functions, I should subtract the area under the graph of g from the area under the graph of f. Therefore, I should integrate f of x minus g of x over the interval from a to b. So this blue region, the area is calculated by this integral. I wrote f of x first because f of x in this picture is over that interval is bigger than g of x. And be careful in such problems, the area should be a non-negative value, in fact, a positive value most of the time, just in case if the two functions are the same functions, f of x and g of x are the very same function, the area is going to be 0. But other than that, usually we get a positive area, but definitely we don't get a negative area. Again, if we get an area of, if the two functions are the same, the area is 0. But if the two functions are not the same, the area is positive. But we'll never get a negative area. Okay, now let's see an example that the equations of the two functions are given. Find the area of the region bounded by one function, y equals x plus 1. One function is x squared. And the two vertical lines, one of them is x equals 0, and the other one is x equals 1. Sometimes the graph is given, sometimes it's not given. Let me, for this example, draw the graph of the functions and see that what we exactly we are calculating. So y equals x squared, as you know, it's a parabola, looks like this. So this is y equals x squared. Y equals x plus 1, as you know, it's a line. Suppose this is the line that gives us y equals x plus 1. So this is the line y equals x plus 1. X equals 0 is the vertical line passing through 0. So x equals 0 is, in fact, y-axis. So this is x equals 0. And x equals 1 is, suppose 1 is here, is this vertical line. So in fact, so this is x, the line, the vertical line, x equals 1. In fact, the region that we are integrating is, or calculating by integrating the difference of two functions, is going to be this region. From 0 to 1, obviously the line of x plus 1 is bigger than y equals x squared. In other values of x, it's possible, which happens, x squared is bigger. But from 0 to 1, as you see, from 0 to 1, the line is above the parabola. Of course, after some point, or before some point, the parabola will be higher than the line. But over that interval, as you see, the line is above the parabola. Like this upper boundary is part of the line y equals x plus 1. And this lower boundary here is part of the parabola, excuse me, part of the parabola of y equals x squared. So when I want to form the integral to calculate that area, we should do the integral from 0 to 1. The bigger function first. X plus 1 is bigger than x squared from 0 to 1. And then minus x squared dx. Of course, if I was integrating, say, from 4 to 5, then x squared would have been bigger than x plus 1. But here I'm integrating from 0 to 1, and over that interval, the line y equals x plus 1 is higher than the parabola of y equals x squared. Okay, so let's calculate this. Antiderivative of x is x squared over 2. Antiderivative of 1 is x. Antiderivative of x squared is x cubed over 3. And I need to evaluate this at the limits of the integral and do the subtraction. So let me continue the calculation here. That function should be evaluated, or that antiderivative should be evaluated at 1, whatever it is, minus the evaluation of this at 0. And 2, we should do the subtraction. At 1 means that substitute 1 for x, which gives me 1 squared, 1 over 2, plus 1 minus 1 squared, 1 cubed over 3, 1/3. At 0, 0 squared over 2 is 0, plus 0 minus 0 cubed over 3, which is still 0. So the second parenthesis turns out to be just 0. And the answer is just calculating this. Just find the common denominator of 6 and do the calculation. The final answer is 7 over 6. In this example, as in some examples, we are told that x runs from where to where. Like in this example, x runs from 0 to 1. But it's possible that we are not given that information, meaning that sometimes we need to find the points of intersection. If it doesn't say if x runs from where to where, we need to find the points of intersection of the two functions and then calculate the integral of the difference of the two functions over that interval. Let me draw a picture first and then explain what I just said on that. Suppose I have two functions. The equations, of course, in an actual problem is given. Suppose this is f of x and suppose this is g of x. And I want to find the area between these two. So first I need to figure out what are these points of intersection. If it doesn't say from where to where, I need to find out what are these points of intersection. Then the area of that region will be the integral from a to b. A and b are not given, but by solving some equation that we'll see in a couple of examples after this, we can find out what a and b are in a problem like this. In this example, which graph looks higher? F of x is higher, f of x first, g of x smaller. What I mean here is over the interval from a to b. From a to b, f of x is above g of x. I'm not talking about before a or after b. I'm talking from a to b. F of x is bigger than g of x. That's why when forming the subtraction, I write that first. F of x first and then minus g of x. So in problems like this, we need to find points of intersection, like to find out what our a and b are, and then do the integral. To clarify this, let me give an example. Find the area of the region bounded by these two functions, y equals x squared and y equals 4x. First, I need to know that at which numbers, for which x's, that these two functions will be equal. In other words, these are the x's that the two graphs intersect. So when I want to solve these, first set x squared equals to 4x and solve the equation. So for this particular example, what is the solution to this equation? Subtract 4x from both sides, so x squared minus 4x is 0. What are the roots of this equation? One of them x is 0, one of them 4. This is a simple equation, of course, but just as a clarification, I factor x out. X times x minus 4 is 0. The product of x and x minus 4 is 0. By setting x equals 0, one root, but setting x minus 4 equal to 0, another root is obtained. So I know that I should integrate from 0 to 4. These two functions, they meet at points that one of them, the x coordinate is 0, for the other one, x coordinate is 4. Now the question is, I should figure out, so secondly, we need to determine that over this interval from 0 to 4, which one is correct? X squared is more than or equal to 4x, or 4x is more than or equal to x squared. This is something we need to figure out. Which one is the correct one? So we know that at 0 and 4, x squared and 4x are equal. What happens between them? You might have seen a similar thing in like basic algebra courses, that we choose a test number from 0 to 4 and test these two functions at that number. Whichever is bigger tells us over that interval the corresponding function is bigger. So from 0 to 4, let me choose a test number from this interval. Any number in that interval works for as the test number. For the test number, we can choose anything. Like, it's better to choose integers to simplify our calculations. Like, let me choose 1. Now, x squared at 1 is 1 squared. 4x is 4. Obviously, 4 is bigger than 1 squared. 4 times 1 is bigger than 1 squared, meaning that over this interval, this happens, 4x is bigger than x squared. Be careful, we are talking about the interval from 0 to 4. Of course, after 4x squared is bigger than 4x, but what we are integrating over is the interval over 0 from 0 to 4. And over that interval, 4x is bigger. So when I want to form the integral, this is the final step of solving this. So finally, to find the area, I just go with the integral from 0 to 4. 4x is bigger, meaning that 4x comes first, then x squared dx. The rest is simple. It's a like Calc 1 type question. Antiderivative of 4x is 2x squared. Antiderivative of x squared is x cubed over 3. Then I should evaluate these at the limits of the integral. This means that evaluate this at 4, which is 2 times 4 squared minus 4 cubed over 3 minus the evaluation of this function at 0, meaning that 2 times 0 squared minus 0 cubed over 3. If you simplify this correctly at the end, you will get 32 over 3. So the answer to this question that we had here is 32 over 3. Let's do another example. Again, in the next example, it doesn't give us from where to where. We need to intersect the two functions to find the points of intersection. So find the area of the region bounded by these two functions, y equals x squared minus x minus 4, and y equals minus x squared plus x plus 8. As usual, I suggest that you pause the video and try to do this on your own. Step 1 is to find points of intersection. Meaning that I set these two functions equal to each other and solve the corresponding equation. X squared minus x minus 4 equals minus x squared plus x plus 8. This is a quadratic equation, right? Let's move everything to one side. Like here, to move minus x squared to the other side, I add x squared to both sides. To move x to the other side, I subtract x from both sides. So far, these two cancel out, these two cancel out. Also, to move 8 to the other side, I subtract 8 from both sides. Now, what I have on the right, for that, I need to combine like terms. X squared plus x squared is 2x squared. Minus x is minus 2x, minus 8 minus 4 is minus 12. That equals 0. Use a method at your choice to solve this quadratic equation. You can use the quadratic formula, or if the coefficients are simple enough that this can be factored, it's better to use factoring to save time. First of all, I noticed that among all the three terms, 2 is in common. I can factor that out. 2 times x squared minus x minus 6 equals 0. X squared minus x minus 6 can be factored as x plus 2 times x minus 3. So from x plus 2 equals 0, I get x equals minus 2. From x minus 3 equals 0, I get x equals 3. So these are the x's at which the two graph intersect. Next, so the integral should be over the interval from -2 to +3. The next thing that we are going to do, similar to the previous example, we should determine over the interval from -2 to 3. This interval that we found the endpoints of that. From -2 to 3, which one happens? Which function is bigger? Is x squared minus x minus 4 more than or equal minus x squared plus x plus 8? Or vice versa? Is x squared minus x minus 4 is less than or equal minus x squared plus x plus 8? Which one? As we discussed this before, we need a test number from -2 to 3. What test number would you suggest? The easiest test number is 0. Of course, you can choose anything as long as it's in that interval. You can choose -1, you can choose +1, or +2. Or even you can choose 1.5, but we wouldn't do that. That just makes our calculation a little longer. So for the test number, we choose 0. Now, x squared minus x minus 4 becomes 0 squared minus 0 minus 4. And I want to compare it to minus x squared plus x plus 0. So minus 0 squared plus 0 plus 8. Obviously, this is bigger, right? Meaning that this is the correct one. Again, be careful. From -2 to 3, this inequality happens. Beyond that, it is reversed. So when I want to form in the final step to answer this question, to find the area, when I form the integral of the difference of the two functions, the bigger function comes first. You know that we have two functions here. The bigger function comes first. What was the bigger function? Minus x squared plus x plus 8. The smaller function is x squared minus x minus 4. So we should do this integral. And we are confident that at the end we get a positive answer. If I get a positive negative number, it means that we have made a mistake somewhere. So let's do that first. Let's combine like terms, of course, to distribute negative over these parentheses. And then minus x squared is minus 2x squared, x plus x, 2x, 8 plus 4 is 12. Antiderivative of minus 2x squared is minus 2/3 x cubed. Antiderivative of 2x is x squared. Of course, after simplifying, it becomes x squared. Antiderivative of 12 is 12x. Then I should evaluate these at these end numbers. Minus 2 and positive 3. The lower limit of the integral is minus 2 and the upper limit is positive 3. So to do that, we evaluate this function at 3, which is minus 2/3 3 cubed plus 3 squared plus 12 times 3 minus the evaluation of this function at minus 2. So minus 2/3 times negative 2 cubed. And then minus 2 squared plus 12 times minus 2. So the rest is just calculating these terms and adding up the integers and fractions. If you do all of them correctly, at the end, the correct answer that you should get is 125/3. So after simplifying these additions and subtractions at the end, you will get 125/3, which is the area of the region, which is bounded by those two functions. Another example, and I encourage you to do it on your own before watching my solution. Find the area of the region bounded by these two functions. One of them is y is x squared, and the other one is y is 8 times radical x. Okay. For the points of intersection, we set these two functions equal to each other and solve the equation. Do you remember from basic algebras how we did these kind of equations? One side has radical, one side doesn't. As you might remember, in such situation, we raised both sides to power 2 to get rid of the radical on the right side. So what I have is x squared, which is x to the 4, 8 radical x squared. 8 squared is 64, and radical x squared is just x. What we are going to do is we subtract 64x from both sides. So x to the 4 minus 64x is 0. X is in common. I can factor that out. X cubed minus 64 is 0. The product of these two is 0. So x is 0. And x squared minus 64 equal to 0, meaning that x cubed is 64. X cubed 64, the only root it has is x equals 4. Since 3 is an odd number, x cubed equals 64 has only one root, one solution, and that is x equals 4. So these are the two x's at which the two functions they meet or they intersect. Now, the next thing that we need to determine is what? Over this interval, from where to where? I just found those numbers, 0 and 4. Over 0 to 4, over this interval, which one happens? Is x squared more than or equal 8 radical x? Or x squared is less than or equal 8 radical x? We need a test number. Choose a simple test number. Calculation is easier. Like from 0 to 4, maybe 1 is the easiest one to test. So test number 1. At 1 squared is 1, but 8 times radical x is 8 times radical 1. Which one is bigger? Obviously, this is bigger. So over that interval from 0 to 4, not anywhere else, from 0 to 4, we have this is the correct order of the inequality. Meaning that in the final step that I want to find the area and form the integral, 8 radical x comes first, and then x squared minus x squared. So the first integral in 8 times, so it's 8 radical x. We had a reminder about radical x. You have seen also in Calc 1 what is antiderivative of radical x, as we have had a review about that before. It is 2/3 x to the power of 3/2. Antiderivative of x squared is x cubed over 3. And then I need to evaluate at these points. Just a little simplification here. It is 16 over 3, 8 times 2, 16 times x to the power of 3/2 minus x cubed over 3, evaluated at these end numbers of the integral. So evaluate this at 4, which gives us 16 over 3 times 4 to the power of 3/2 minus 4 cubed over 3. At 0, that's easier because both of those terms become 0. 0 to the power of 3/2 and 0 cubed are 0, so both terms are going to be 0. Just you write 0. So the second parenthesis is just 0. It remains to calculate this. What is 4 to the power of 3/2? 4 to the power of 1/2 is like radical 4, like 2, and 2 cubed is 8. So this part is 8. 8 times 16 over 3 is 128 over 3. 8 times 16 is 128. Then minus 4 cubed, this is 64. 64 over 3. And obviously, this difference is they have the same denominator of 3. 128 minus 64 is 64. So the correct area for this region is 64 over 3. And this cannot be simplified. 64 has no factor of 3. So this will be the final answer.